Good afternoon. As you can see on the screen, 26 people are there before the time, before 27 now. And these should be counted before time because if you see in this corner, there is still 1 minute to go. So I have 1 minute to honor these people by taking their names who are there in the class before time. अतुल वर्मा, अंश भाटिया, मुदित, प्रत्युषा कुमार, पार्थ शर्मा, नवनूर कौर, शिवांगी साहा, उमंग गुप्ता, पार्थ शर्मा, राघव शर्मा, श्रेयशी झा, प्रथम गुप्ता, मृदुल शर्मा, अक्षत बहल, दीपक राजपूत, पल्लवी थापर, विजयलाक्षी चिल्लर, कृति राव, अद्रियान देव, रॉय, भूमि चौधरी, यश जॉली, प्रियांशु यादव, ख्वाहिश जायसवाल, अभिलाष सिंह, सन्ना श्रीवास्तव, उद्भव यादव, ऋत्विक भाटिया, शाश्वत शर्मा, आदित्य कुमार सिंह, अनिकेत चट्टोपाध्याय, वसुधा राणा. Now 34 people, 37 are there, and if you see the time, now the time is 2 o'clock. So 37 people are there on time. The funny part is this. I have not even started the class and there are 4 likes of the class. Thank you so much. Your presence encourages me. Some more have joined, and because it is just the time, I'll read out their names also. I read up to Shashwat Sharma, Aditya Kumar Singh, Aniket Chattopadhyay, Vasudha Rana, Abhi Abraham, Shivena Garwal, Ritesh Wadhwani, Pranshu Lakhotia, Manya Sareen, Swastik Baranwal, Rudra Chaudhary. Good afternoon, everyone, and thank you for being on time. Now we will start the class, and I will not be able to respond to your good afternoons now. So far, what we have done is that we have found the normal reaction in certain cases. How did we get this term normal reaction? We started with the 2 cases. One was the block was kept on my hand, and even though the gravity is pulling it down, but the block is not going down. So the block at rest remains at rest even though there is a force on the block by the earth trying to pull it towards its surface, towards its center, but the block at rest remains at rest, which means someone must be holding it, and you can see who is holding it. I am holding it, so I am applying some force in the opposite direction, opposite to the direction in which earth is pulling it. I am applying some force in the opposite direction. Now who is applying more force, the earth or me? Now because the body at rest remains at rest, so the net force on this body is 0. The net force on this body is 0. So the force applied by the earth and the force applied by me, they are equal and opposite. Equal and opposite. But then we discussed in the previous class, that does not mean that these two forces form action-reaction pair. I hope you remember that. Those who did not attend the previous class, I request you to go through the recording. Teaching on YouTube has this advantage that those who are not able to come live, they can see the recording which is available within half an hour. It becomes available on the channel and you can watch that recording. So once again, block at rest remains at rest. It means net force on this block is 0 and the earth is pulling it down. I am pushing it up, and because the block at rest remains at rest, these two forces are equal and opposite, but they do not form action-reaction pair. We saw what forms action-reaction pairs. In the previous class, we saw that. Today, we are going to find that value of normal reaction in the remaining cases that were left out in the previous class. We are going to find out those normal reaction cases today. So block is kept on a slope. You need one knowledge, one information that you require is this. that we use in the previous time that we used it. Uh, the force along X, how much is it along Y? Then we saw the quick, easy method. We saw even the reason for it. But then later on, we learned it as a system that the side we have theta, it will be 5 cos theta this side. This side, the force is 5 cos theta. So this side it is, you call it 5 cos of 90 minus theta, or you straightway say the another one is 5 sin theta. So you can replace this 5 Newton acting in this direction by two forces, 5 cos theta along x and 5 sin theta along y, and these two situations are exactly identical. We used this knowledge to find out the normal reaction in this case, and Ritesh Wadhwani is giving the correct answer. The normal reaction value of normal reaction is equal to mg cos theta. We have done that case. Then we saw these cases. In this case, n was mg minus p. We have done that. In this case, n is equal to p plus mg. In this case, p cos theta this side, p sin theta this side, n is mg minus p sin theta. And in this case, this is p cos theta this side, p cos sin theta down. So mg plus p sin theta is equal to n. This much we have done in the previous class. Now I am coming over to this case when there is a lift, and in the lift there is a person, and this lift is moving up, is going down, and various cases are there. It is moving up with some constant speed, it is going down with constant speed, it is moving up with some acceleration, it is going down with some acceleration. And when it is going down with acceleration, there also there are various cases that acceleration is less than g, that acceleration is equal to g, that acceleration is more than g. All these cases we are going to discuss today. So let's begin our today's class, and let's decide this case. So what we know so far, we will build up from there. What we know so far, one of the things that we know as a basic law is this, that net force is equal to ma. We have been talking about this law right from our first class on laws of motion. Remember that. To remind you, these classes target are those students who want to study physics in class 11th, but either they are weak in math, or they don't like math, or they are scared of math, but they are not scared of physics. Rather, their mind works very well in physics. When lift goes down, we feel, I will do that. Mudit, we will do that. We will discuss that case. For example, many students who prepare for medical, they are weak in physics just because, you remember that in PK there was a dialogue, wrong number dial kar diya, wrong information feed kar di, that they are poor in math. In last 4 or 5 classes that I have held with you, I have proved to you again and again that you are naturally good in physics if you are observant. If you observe things, you are naturally good in physics, and you people have been impressing me with your natural intelligence. So these classes, they don't have much of math in them. Physics is discussed as physics, and math is not stressed upon. So that is intentional. And even this is intentional, that I started with laws of motion and I did not start with unit dimension, with kinematics, all those things. I will, wherever I have needed it. For example, I needed vectors. We have managed it with the least possible math that we could. So net force is equal to ma. This requires finding resultant, and some resultants are very basic. You can find them. For example, finding resultant of these two forces, F1 and F2, very easy. Finding resultant of these two forces, F1 and F2, very easy. But then when it comes to things like these, that there is F1 here, there is F2 here, this is say theta 1, this is say theta 2, all these kind of things, then you start needing some kind of training, some kind of knowledge in vectors. Then that's where you require it. And I said I will take a formal class on vectors also, but we are restricting ourselves to common sense physics, common sense physics. Okay. So this is a basic law, net force. When you find net force by whatever means, the vector resultant, you put it equal to ma, and you get A is equal to net force by m. This is a basic equation that we use it. We will, once we come to kinematics, we will see what we do after finding A, all those things that we will do. But right now for today, we utilize this thing when A is 0. Remember that net force is equal to 0, and we utilize it to find n so far. Today we are going to do those cases of lift using this simple equation. So say this is a lift, base of the lift, and in the lift a box is kept. You know about this force, this is called the weight, and you know that the surface of the lift, the bottom, the floor of the lift, it applies a force in the upward direction. You call it either N or R, normal reaction, normal force, whatever name you want to call it. And remember, so far we have seen that N equal to mg kind of thing. Now case 1, the lift is going down with the constant V, or the lift is going up with constant velocity. For both these cases, V equal to constant, velocity equal to constant means that acceleration is 0. Is this part clear? Whether V is down or V is up, till the time you have velocity equal to constant, this velocity equal to constant, velocity equal to constant, whether up or down, if V is constant, then acceleration is equal to 0. Now we use that thing, that net force equal to ma. So whether I find net upwards or downward, whether you say n minus mg or you say mg minus n, it is equal to 0, and n will be equal to mg. So very good. So these two cases, say v up, v down, but constant. These are identical to v equal to 0. And that's a very important conclusion. In physics, there is no way that you can differentiate between cases where v is, say, the train is at rest or the train is moving with constant speed, because these motions are relative. It is only when acceleration is there that you start realizing that laws of physics for one person and for another person, they have a difference. These cases, say for example, lift is moving with constant speed up. Now, do not get confused with one thing, sir, we can feel it. We are talking about experimental measurements. What do you measure that you can differentiate between the two cases, that the lift is at rest or the lift is moving with constant speed? These are the things which might shock you. What might shock you? The world would be exactly identical. Now, if you find that I'm talking nonsense or I have had some wrong kind of drink in the afternoon, you are free to think that way, because that's how the world is. But it is equally possible that the lift was at rest and the whole of the world, the building, the frame, that moved down. If you find it ridiculous, it is. But a lift going up with a speed of 5 meters per second is exactly the same that the lift was at rest and the whole of the world was moving down with a speed of 5 meters per second. There is no way to differentiate between these two cases. So your train moving with 5 meters per second is exactly same that the train is at rest and the platform, the track, the railway station, everything together schemed and planned together that they moved with 5 meters per second in the opposite direction. The train was actually at rest. Sir, to detect motion, we should be in inertial frame. No, motion is a different thing. Inertial frame means non-accelerated frames. Inertial frame doesn't mean moving or not moving. Inertial frame means non-accelerated frame. This case is the same as a case when lift is at rest. Yeah. So lift at rest or lift moving with constant speed are identical in physics. In both the cases, you will get N equal to mg. And I said a train moving with the speed, constant speed of 5 meters per second, and a train at rest will give you the same kind of results in the experiments. When things are accelerated to each other, then it is a non-inertial frame. These words sound heavy, but what they actually mean. Remember last time I was telling you charged rod and pith ball and all these things, what they mean? Actual life, what do they mean? A drinking straw and tissue paper, they rubbed it together and then they connected to the thermocol ball, styrofoam ball, wrapped in a kitchen foil, metal foil. Actual terms are very simple, very easy. So inertial frame, non-inertial frame, if you feel they are heavy terms, well, that's a way we physics teachers have designed to scare people away. Frame of reference is generally specified. Yes, sir. What is non-inertial frame? We will come to that. We will come to that. And I have certain tools to discuss even those kind of things when it comes. We will be talking of pseudo forces in this course itself. In laws of motion itself, we will be talking of pseudo force. And I have made these arrangements that there is a boy, actually looks like a monkey, but a boy, and there is a girl, and one moves with the train, and one can stand on the ground or can come in the train, is movable. We will utilize all these things and we will study in this course itself. We will study the topic of pseudo force. We will study, but volume is low, should not be. Actually, the connection today is very bad. Yes, Rudra, yes, no. Yes, no, might be. We will discuss. When time comes, we will discuss. Actually, right now, I'm in no hurry because even if your classes, coaching classes are going on, no, you use earplugs. I have no point of using earplugs because I'm not hearing you. I'm reading your comments. I don't need earplugs, but then if you put earplugs, that would be better. So what I'm saying is, no coaching institute is teaching you laws of motion. I'm not running short of time. I can discuss each and everything easily with you, and I see that you people also take interest. Every time I see that more than 20 people, they are in the class before time. I have time and I like spending time with you. I enjoy spending time with you. So I will go with the kind of the speed that I'm going. So one case that we have discussed, we lift going up with constant speed, lift going down with constant speed, doesn't matter. Both are exactly identical. Now let me move on to the case when the lift is getting accelerated. So to begin with, lift is going up with an acceleration A. Mudit, we will come to pseudo force. I will teach you pseudo force. And you have seen that I have put all those arrangements, used those things to explain pseudo force. We will do that. We will study. Don't worry. Ritvik, I understand that. Coaching Institute is teaching optics to class 11th. Even I can teach you optics. I have lot of things with me. Lot of lasers I am having. Green laser, red laser, white light. I am also having lot of things with me for optics. Rather lots and lots of things. Okay. So the normal reaction acting up, mg acting down, and I am taking this case when the lift is going up with acceleration a. Now common sense says Parth says a non-inertial reference is a frame of, they are not accelerated, which means either they are at rest or they are moving with constant speed, then we call them inertial frame of reference. Would you run a concurrent course on optics? Actually, if class 12th takes interest, I can run a concurrent course on optics. Because for class 11th, it doesn't mean much, except for fun. Might be for the sake of fun. Oh, then I can call even class 9th, class 10th to have fun with optics. That kind of fun course we can have, or one or two classes we can have. That we will talk about later. Okay, now here in this case, common sense says if something is getting accelerated up with acceleration a, then out of n and mg, which one is more? Common sense says that n should be more, so n minus mg is the net force upward, which is giving acceleration a. Let me put it a naught, because a looks like a general word. N minus mg is the net force, which we put equal to ma, and so it will be ma naught. Is that okay? Because the whole thing is having acceleration upward a naught. So when I say net force, so basically what I have done is net force equal to ma, and so net force is n minus mg. I have put it equal to ma naught. Okay. So how much is n? N is equal to m into g plus a naught. N is more than mg. I'll give you an easy way to remember this result. Easy way to remember. If I am holding something on my hand is feeling that push down if I'm holding it. But in this condition, if I have to throw it up, I will have to apply more force than what I was applying in holding it. In holding it, if I was applying some force, and now if I have to throw it up, I will have to apply larger force. So n, when you are accelerating things up, n will be m into g plus a naught. Okay, it will be more than mg. Now, if this acceleration is down, I'll keep it here on the screen. If this acceleration is down, so this n and this mg, and say acceleration is a naught down, then same thing, net force equal to ma. So this time mg should be more than n. Mg minus n is equal to ma naught, and n is coming out to be m into g minus a naught. Easy way to remember, if I'm holding it with some force I have to apply. If I'm feeling tired, you let it go. Let it go. The hand feels easy. Let it go. So when you let it go, your hand has to apply less force. So n will be less than mg when you let it go. Now we come to those cases when a is less than g, is equal to g, or is more than g. If, let's take an example. If a naught is less than g, example, g is, let's say, 10. This is a rough rounding off that we do in most of the question in class 11. When 9.8 is not easy to calculate many times. Sir, if it is down, then ma would be down. So that's what I have done. I have taken here what I have done is down I have taken as positive, up I have taken as negative. So you see mg was down, है ना? And a naught is down, n is up. So I have done mg minus n is equal to ma naught. Vijalakshi, have I answered your question? So if a is less than g, say g is 10 and a is, let's say, say 5, say, let me make it, say 6 meter per second square. Down. So upward is positive. Okay, Swastik, let me answer this question properly, give you some time, because otherwise you might feel confused. Which one is up and which one is positive? Say up or down, which one is positive, which one is negative? It depends on you. Usually when nothing is given, then we go by these conventions. Say this is positive, this is negative, this is positive, and this is negative. We go by these conventions when nothing is given. But then suppose you say, I am going to take this as positive, then only restriction is that this should become negative. Okay. Now suppose you say this direction is positive, then only restriction on you is that this direction should become negative now. You can't have this also positive and this also positive. That you can't have. Okay. Otherwise, actually there is no restriction. That depends on you. But that whatever convention you take must be a sensible convention. Okay, so this one gives me n is equal to, let's take m equal to, m also equal to say 2 kg. So m equal to 2 kg, 10 minus 6. So this becomes 8 Newton. 8 Newton. If it was a equal to 0, then it would have been 20 Newton. If a is equal to 0, it was 20. Now it is less than 20. Now what if a is equal to, what if a is equal to, a naught is equal to g, n will be equal to m into g minus a naught is equal to g, n is coming out to be 0. What does n equal to 0 mean in physics? N equal to 0 means, see what was this normal reaction signifying? The force applied by the surface. And n equal to 0 means they are not touching each other. They are not pushing each other. They are not applying force on each other. So let me introduce you to some sentences, terminology in physics, the way they say it in English and the way they mean it in physics, the mathematical form of that English. A term used is loses contact. Loses contact. Say something is moving and it jumps, it loses contact with it. Say for example, someone walking on a surface jumps, loses contact. That is an English sentence, English term, loses contact. How do you put it in physics? In physics, you put n equal to 0. I'll come to free fall also. N equal to 0. N equal to 0 means it loses contact. That right now, this was on my hand, applying some forces. But then suppose you lift it up, the moment it lifts up, there is no force on each other. They lose contact, n equal to 0. But then another situation comes. If a naught is greater than g, say example, g is 10, a is 12 meter per second square. This is also 10 meter per second square. What will happen in that case? Let me try and focus the camera in a way that you are able to see what happens. Are you able to see it? Let me increase the size of the video so that you are able to see it better. This facility is there in YouTube. Okay. Now look at it. This is that body. This is the lift, and this is the lift going down with constant speed. Okay. This is the lift going up with constant speed. I will take this lift down with an acceleration greater than, let me change the body because this is not much visible. I'm changing the body now. I will take this lift down with an acceleration greater than g. Look carefully. Did you see that? Action replay. Action replay. Could you see that? Okay, let me do it the other time. Did you see that? What happens? Last time. Could you see? These are little bit fast phenomena. Later on, if you are seeing the recording, you can see it with a at slower speed. What happens is it loses contact. Now the moment it loses contact, now they, let me bring the size back to, so that I'm able to write. Okay. Uh, okay. Okay, we are talking of this case now. A is greater than G. Now, if I put n equal to m into G minus A, and I put those values, I get a very wrong answer, minus 4 Newton. Yeah, see, loses contact. The moment it loses contact, your n is equal to 0. This n minus 4, we will talk in a short while what it means, but your answer is n equal to 0. It loses contact. There's, yes, Raghav, yeah, right. There is a gap between the two. When you move the notebook faster than G, then it loses contact, even though the answer is coming out to be minus 4, but the answer is n equal to 0. N equal to 0. Why? Because it has lost contact. The moment it loses that touch, n becomes 0, that is your answer. But then, is there any case possible that this minus 4, does it make any sense anywhere? Anywhere? Does it make any sense anywhere? Okay, let's talk about this case. Now let me make this lift like this. And there is another lift which is closed from above. This is open lift, open from above, open from above. Now don't tell me which building has such kind of lift. In physics we have these lift, okay? And this is closed from above. Now both these lifts, they move down with A equal to 12. This also moves down with A equal to 12, okay? What do you expect in this case? The lift will go with 12 down, but this block, now let me change the color, but this block will come down with A equal to 10. So what you saw just now, that thing will happen. Lift will go down, it will lose contact, and your n will be equal to 0. It loses contact. But in this case, what do you expect? When this goes down with the 12 and this is going down with the 10, what will happen is, after a while, these minus signs, they have a meaning in physics. Minus 4, 4 Newton and minus 4 Newton, minus 4 Newton means opposite direction. Sir, battery, and what happens is that the roof of it will push it down, and that is 4 Newton. That is 4 Newton. Yes, I can show it to you, and this time I'll show it, but then seeing it in this camera is little difficult. We will do this case in the school, but then you can try it out yourself. Hold a pencil like this, say eraser like this, and put your two hands together like this, together. Okay? Let me do it for you so that you know what to do, try at home. Hold it like this. And now you bring both the hands down. Let me increase the size of the video so that at least you are able to understand what to try out yourself. So this is what you are going to try out yourself. Okay? It is minus sign is the direction. So you hold it like this. This is the eraser. And keep your two hands like this. And now move both the hands very fast down. And note what happens. Note here with this hand what happens. Okay? See. Did you see? Could you see? and both hands move very fast. I'll do it again. You try it out yourself now. You move both the hands fast. Did you see what happened? This top wala hand goes and hits the eraser and it pushes it down. Pushes it down means that 4 Newton, when you say minus 4 Newton, this is what it means. We have come to a close of this normal reaction, finding normal reaction. Next class onwards, we will start talking about motion of connected bodies. I will keep this class to a minimum math, as little math as can be, and we will study the motion of connected bodies. What does it mean, motion of connected bodies? That this block will be joined to another block and we will pull those blocks together and we will see if this rassi, this string is tight. We will find out, calculate how much is the tension in this string. Then we will study friction and again we will do the motion of connected bodies, that how much is their tension in this thing. Then we will have a pulley. Over the pulley we will pass a string over the pulley and we will connect bodies on two sides and we will find out how much is the tension in the string, the major part of all these activities. The upper hand, yeah, object comes in contact with the top. So, sir, does it mean that the lift ceiling will push the battery with 4 Newton? Yes, down. The lift ceiling, yes, will push it down with 4 Newton. Yes, that's what it means. Minus 4 Newton, that's what minus 4 Newton means. So go through those videos once again if you want. In my expectation is that you should be able to find normal reaction in most of the cases that you have in your books. You should be able to find it out. Should not be a big difficulty. Only thing in mathematics that we required so far was those components of a vector, which are technically called components of a vector. That if you have one 5 Newton force at one some particular angle, and you want to replace that 5 Newton force with the two forces in perpendicular direction, then remember that 5 cos theta, 5 sin theta, all those type of things. Sir, is there tension in a string connected to pulley? Yes, yes, there is, and we will be finding it out. Also, we will be doing these cases where people don't agree who is applying force, all those pseudo forces, etc. Also, we will be doing. So, thank you so much. See you again next Tuesday at the same time, 2 o'clock. And thank you for encouraging me also when you come before time, when you show interest. I feel very much motivated to continue these classes. Thank you so much. See you on Tuesday, 2 p.m.